The next thing that we're going to look at today with the rational functions is how to find several different pieces of information from them. The first thing that we want to find is the domain. Then we're going to find the x-intercept, and we're going to find the y-intercept. And in a moment, after we're done with that, we'll find what we call the horizontal and the vertical asymptotes. We talked about those a little bit when we were graphing the basic rational functions, but we'll talk about them a little bit more in depth as we look at a little bit more complex rational function. Now, the difference between this and the ones that we've done already is looking at the numerator and denominator, both of them have x. And if we were to try to simplify this expression, we would be able to factor out the denominator and see that we have multiple terms down there. So we no longer can use just our basic transformations of left, right, up, and down. We have to think about things a little bit differently. And as we gather this information, it will help prepare us for graphing these more complex functions next time when we come to class. So looking at this, if I wanted to factor this out, the x plus 7 I can keep as the numerator, that doesn't change. But factors of 15 that add to 8, if I'm trying to factor this denominator, I could say x plus 3 and x plus 5 would be those two factors. Because 3 times 5 is 15, but 3 times 5 is also 8. Or 3 plus 5 is 8. So I can look at those and see that I now have a couple of domain restrictions. If we think about rational functions or fractions just in general, the one value that I can never divide by is 0. I can't take a number and divide it into 0 pieces. It just doesn't work. So if I look at these two denominator pieces, for my domain, I would have to say that x cannot equal a -3 and a -5. And the reason for this is if I take that -3 and substitute it in for the x plus 3, -3 plus 3 is going to give us 0, and that x plus 7 divided by 0 is not possible. The same thing is true when I take the -5 and substitute it in for the x plus 5. -5 plus 5 is 0, and anything divided by that 0 is not going to work. So those two values are going to be values that I can't let x equal. And we'll come back to these values in a moment when we talk about vertical asymptotes. So the next thing we want to look at is x-intercepts. X-intercepts are where we cross the x-axis. And the way we can find that is think about what the value of y is on the x-axis. The value of y is going to be 0. So what I'm going to do is take a 0 and set it equal to my function, but really just the numerator of the function. So if I take 0 and set it equal to the numerator, I can find my x-intercepts. So in order to solve this, I'm just going to subtract 7 from both sides and get x equals -7 is my x-intercept. If I want to solve for the y-intercept, I need to figure out what a y value is. So I'm going to eliminate my x's and put zeros in their place. So my y value for the y-intercept using the original function will equal 0 plus 7 divided by 0 squared is 0, and plus 8 times 0 is still just 0, and plus 15. If I simplify that down, I end up getting 7 over 15 for my y-intercept. So we found the domain, we found the x and y-intercepts. The next thing we want to be able to do is solve for what we call the vertical asymptotes, which were those boundary lines that we had on the original graphs, and the horizontal asymptote. The vertical asymptotes are the two places in this case where my domain is not defined. So instead of saying x can't equal these numbers, I'm going to instead say x equals a -3 and a -5. If we would look back at the original function here, I would want to say, if I ignored the x plus 5, if I had that x plus 3, that's a shift to the left 3 for my asymptote. So my vertical asymptote, one of them is -3 for x. Similarly, if I look at the x plus 5 term, that term would have been a shift to the left 5, resulting in that x equals -5 vertical asymptote. So the domain restrictions and the vertical asymptotes are going to go hand in hand, because the domain says where we can't actually have a piece of the graph. The vertical asymptote is describing what that piece of the graph is, that boundary line, in this case -3 and -5. Now the horizontal asymptote, that's going to be that horizontal boundary instead of the vertical boundary. What we want to do is look back to our dominant powers of x. So if we look back to our original function, that's going to be our x and x squared terms here, because x is the highest power in the numerator, x squared is the highest power in the denominator. So if I look at those, my horizontal asymptote is going to be a comparison of x to x squared. And if I divide x by x squared, one of those x's is going to divide out, and I end up with 1 over x. Now, a horizontal asymptote is describing what happens to the function as x gets really large. So if x was 100 million, or even larger than that, if I take 1 and divide by an extremely large number, those pieces are going to get smaller and smaller and smaller. So in this case, if I'm looking at that, I could say that my horizontal asymptote is going to be y equals 0, because that's what that fraction is approaching as x gets extremely large, either in the positive or the negative direction. Now, if I ever get a number over x, or a number over x squared or x cubed or anything like that, I can then say that it fits into this category of y equals 0 being the horizontal asymptote. And we'll do another example where that isn't necessarily going to be the case where y is equal to 0, because other conditions end up happening. So we found the domain, both the intercepts and both the asymptotes here. Now let's go ahead and try another function. So let's consider the function y is equal to 3x plus 5 divided by 4x minus 8. And I want to find the same values, or the same types of values that I did before. I want to look at what is our domain. I also want to look at what is our x-intercept, what is our y-intercept, and then we'll get to the horizontal and vertical asymptotes in a moment. So domain, we want to look at what's going to make our fraction undefined. And in this case, it would be if 4x minus 8 were equal to 0. If I were to solve this equation, I would end up getting x equals 2, because I'd have to add the 8 over, divide the 4 off, and I get x equals 2. But my domain, I don't want it to equal these values. So instead of saying equals 0, I'm going to put a slash through that and say x cannot equal 0, and then finally positive 2 once I get down to that. So my domain restriction here, I would have to say is x cannot equal 2, because that 2 would give us a 0 down in the denominator. In similar fashion to what we did in the previous problem, to find the x-intercept, what I'm going to do is set the numerator equal to 0. So 0 equals 3x plus 5. And in solving this, if I subtract the 5 from both sides, I end up getting -5 is equal to 3x. So my x-intercept would end up being x equals -5 over 3. And then finally, if we want to find the y-intercept, instead of plugging a 0 in for y, I want to solve for y, so I'm going to plug a 0 in for all my x's. So my y value for the y-intercept would end up being 3 times 0 is 0, and then plus 5. And then in the denominator, 4 times 0 is 0 as well, and then minus 8. And then I can simplify this expression and get 5 in the numerator and -8 in the denominator. That then would be my y-intercept. So let's go ahead and come up to the other side here and find the two other values that we were looking at. So if I wanted to find a vertical asymptote and a horizontal asymptote, let's start with the vertical asymptote. The vertical asymptote was that boundary line where our domain had a restriction. So in this case, our domain was x cannot equal 2. Our vertical asymptote is going to be x equals 2. So it's that same value. The one is describing the actual boundary line. The other one's just saying what value of x our graph is never actually going to touch. And then we can look at what is our horizontal asymptote. So the last function, we looked at our dominant powers of x. So if I come back over here to my function, I have 3x and 4x as my highest powers of x in both the numerator and the denominator. So I'm going to look at those two values, 3x and divided by 4x. If I divide those terms out, 3 doesn't divide evenly by 4, and that's okay. But x does divide x, and I would just be left with 3 over 4. Last time we had an x in our equation for the horizontal asymptote, which led us to believe that we would have a horizontal asymptote at 0 because it reflects or resembles the original function of 1 over x. In this case, we end up just getting a value of 3/4. So our horizontal asymptote is going to equal that value of 3 over 4. That is our horizontal asymptote, and our vertical asymptote was x equals 2. So again, we've gone through a lot of work to figure out these values. I want to do one last example of just finding the horizontal asymptote, because I feel like that's the one that students struggle with the most. So let's just do one last one. Let's say y is equal to 5x divided by 3x plus 9. And all I want to do with this is find our horizontal asymptote. So our horizontal asymptote, again, we're going to look back at our dominant terms, our highest power of x in the numerator, our highest power of x in the denominator. So I'm going to compare the 5x and the 3x. And if I divide those out, x's again are going to cancel and just leave us with 5/3. So our horizontal asymptote will be y equals 5 over 3. Okay, in similar fashion, if I had, say, y equals 1 divided by x squared plus 9. Let's look at finding the horizontal asymptote of that. Horizontal asymptote, I want to look at my highest powers of x. In this case, I don't have a power of x in the numerator. So I'm just going to look at the 1 over x squared. So 1 over x squared doesn't simplify at all, but I recognize that I've got just a number in the numerator and some power of x, an x squared, an x cubed, something of that nature in the denominator. So that's going to tell me that I have a y equals 0 horizontal asymptote. So if I divide those dominant terms and get a value, like the 5/3, that becomes my asymptote. If I divide the dominant terms and I end up getting a number over a power of x, whether it was 1, 2, 5, doesn't matter what that numerator piece is. If it's just a number and divided by an x or an x squared, my horizontal asymptote is going to be at 0.